Okay, this is the project. It is a TCP and HTTP server, NodeJs server. As the instruction says here, this is a multi-purpose server. It can serve one or more clients. A client can be a web browser, a front-end application or entity such as React.js app, Vue.js app, or a plain old HTML, CSS, JavaScript application. A client is not only limited to front-end entities. A client can also be a back-end server such as Laravel application, Django application, or another NodeJs server application. For specifications here, this project is built with ExpressJs for HTTP web route, Socket.io for TCP route and real-time communication, MongoDB, not Mongoose, for database, and Redis and Redis adapter for caching in-memory data storage, and for message broker. Now the main design pattern used here is the MVC design pattern, Model View Controller design pattern, and it uses object-oriented programming, the ES6 way, and functional programming, the ES6 way. Now I will not bore you by reading the instructions here or reading over the projects here. But the one thing I would like to point out, which is probably the most important here, is this part here. It says almost all the classes inherit a single node-based API class, the transform API. And now the reason I'm making these videos here for this specific project is, even though it says this is a TCP and HTTP Node.js server built with Express, this is probably nothing like a backend server built in Node.js and Express you have seen so far, or it is nothing like most of the Express example or code you see over the internet. This is a little bit different, and it's a design with a complete different mindset. Now to understand what I mean, let's get back to the code. We can clone it as it says here, but I already cloned the project on my desktop, so let's get right into it. Here is the project. And as I said, that it is built with a different mindset. Let's get into it to see what I mean. And the most important part, or the critical part of this project, is this class here. This is the base class. And I say it is the most important because this is the heart of the project. As the instruction says here, it says almost all the classes inherit a single Node.js API class, the transform stream. And that's what it is here. All the classes either uses this class or inherit this class here. And since it is the heart of this class, I would like to go through it and explain it a little bit before we get into all the entire project. Now the question you may have in mind probably is, why even have such a class in this place? Can't we have something that's easier or maybe straightforward? And yes, you have a reason for it, but please bear with me. There's a reason for us to use this class. There's a reason for this class, and it helps us take full advantage of the most powerful thing in Node.js, which is the Stream API. And also by understanding this one, we also be able to take full advantage of the whole project and the real power of Node.js. Now, let's try to understand this class. As we can see here, it is called the base class and extends the Node Stream API. And now, what is the Node Transform API? Because here it extends the Node Transform API. Now first, what is the Node Transform API? The Transform API is a duplex, which in turn extends the Node Event Emitter class. Now, we are not going to dig into Node Event Emitter class or other APIs, but we'll focus on what we have here. And what I want to explain here is what we have in the constructor of this class here. Let's start from top to bottom. Here we have the base class extending the Node Transform API class. This is why we have the super method in the constructor. And as we can see in the super method in the constructor here, the super takes an argument, an object with 3 keys: the object mode, the encoding, and the auto destroy. Now, what does this object do? Or what do the keys of this object do? Now, the object that is passed to the super method here is somewhat unique to the NodeJs Stream API. In our case here, it is somewhat unique to the Transform API. Now, by uniqueness, what does it mean? To understand it, let's see what those things do. What exactly does each of those keys do? Let's start with the object mode. Here, the object mode is set to true. Now, what does it do? Well, when the object mode is set to true, it tells the stream, the Transform API, that when data is streamed through or by the Transform API, it should be streamed in object mode. What does it mean? It means if you were to see physically the data being streamed through the object mode, you will see them go through in an object mode and not into binary mode or anything else. So basically, when the object mode is set to true, it means that when object is streamed through the Transform API, they are streamed in an object mode. That's what it means. And the coding here also is set to UTF-8. It means when object and data is streamed through the Stream API, the encoding should be UTF-8. And its auto destroy when it's set to true, it tells the stream that whenever the Stream API, the Transform API has done streaming, it should destroy the stream, basically. So basically, that's what this object does. Now the next thing we have here is this thing here. It says object keys option for each key. This key equal option key. Now, this option here, it is the option that is passed in the constructor of this class. So what it means here, it says here, for each key on this object, add the key to the prototype of this class. Again, when this class is instantiated, whatsoever object it is passed to the constructor of this class, it says take each key of this object here and add that key to the prototype of this class. Now we'll see how that works, but that is the meaning of this one. That's what it does basically. And then we notice that we have those 4 methods here as well. What do they do? Now let's go one by one. The first one is autobind method. Now this autobind method takes argument this class, which also means this class has a method whose argument is the class itself. Now what does it do? To understand it, let's go to the autobind method. Here we have autobind method. It takes an argument, a class name, and what it does, it calls the autobinder and pass that class name to the autobinder method. So now to understand the autobinder, we should go to the autobinder method here. Here is the autobinder method. It takes in a class as an argument, and then it loops through the prototype of that class. And then by looping through, it looks and checks if the property on the prototype of that class, if the type of that property is a function, and if the type of that property is not a constructor. So it checked if the property on the prototype of the class that is passed into the method is a function and is not a constructor. If it is a function and not a constructor, it binds this property, which is then a method, to this class. Now, this class is not this class. This class here, it is this one here, this class. So this here does not point to this class here, but this here means this class here. Now, why do we do something like that? Why do we even need something like? What does it do? Can we just avoid it? Of course, you may avoid it, but not exactly. What it does here, the benefit of that is that whenever we have this auto bind here, it binds every method of this class here to this class. So we do not have to use we do not have to bind each method of this class to this class manually in the constructor. So it does it automatically for us here. So we do not have to repeat ourselves. Now this may sound a little confusing, but we can see one example, for example, here. Let's go to React website, for example, here. I don't want to distract you, but I thought about this one. This is a React component here. It is a class that extends this one. Now this is a method here on this React class. Now they have to take this method here and bind it to the class here. So that means each method they have here, they have to bind that. So the list is going to be very long. So each method, when they want to use this, they have to pull that thing, this class and this method, and bind it to this class in the constructor of this class here. As the comment says here, it says this binding is necessary to make this work in the callback. So that means if they have 100 methods here, they have to copy this one 100 times and bind it to it. We don't want to do that ourselves. We don't want to do it in the project. So that's exactly what this one does. it binds all the method here. So instead of having all the list of 100 methods, whenever a method is added to this class, immediately it binds it for us here. So that's what it's doing. And I hope this is clear. Now the next one we have is the auto invoker. It also takes an argument, the class itself, the class name here. Now what does it do? To see it, let's go to the auto invoker method. This is the auto invoker method here. It takes argument, a class name. Now it loops through the prototype of the class name which is passed in here, and then it checks if the type of the property on the prototype of the class that's passed in is a function and not a constructor. If the type of the property on the prototype of the class that's passed in here is a function and not a property, and then it then checks if this property is in this array here, Now in this array here, let's see what this one is. This array here is this function here. So this method here takes and return the list of method on this class in the form of strings. So for example, this method here belongs to this class, but the name of this method is passed into this method here as a string. So this is the array. So here, this auto invoker checks if this property is in this array. If it is, then it invokes it immediately. So it means if you want a property to be invoked immediately, first, it has to be on the prototype of this class first. And then when it's on the prototype of the class, we have to pass that thing here. Then it will be automatically invoked. Now, what do we do something like that? It makes things very easy for us. One example here is this one, for example, here. So when this class is instantiated, what this method does, it checks if this property is on the class. If it's not, it just assign it to this one here. So we don't have to add it physically or manually anymore. It's just there immediately. So that's one of the role of the auto invoker here. The next one we have in line is this method here is called metodizer. Now what does it do? To know what it does, let's go to it here. This is what it does here. This is the metodizer method here. It takes argument list of class names. So for each class, it checks the prototype of that class. For a property of the property, if the property of the type of the property is a function and the type of the property is not a constructor. But first, it checks to make sure if the property found on the prototype of each class is not already on the prototype of this class here. So just to explain again, when the class list is passed, it checked the prototype of each class passing it. And first, it makes sure if the property found on the prototype of each class is not already on the prototype of this class. And if it's not on the prototype of this class, it checks to make sure that the type of that property is a function and is not a constructor. If it is so, then it adds this property on the prototype, which is then a method or the function, and then it adds that method on the prototype of this class. And also it binds that method to this class. Now, it seems like it is kind of extending this class. It's kind of extending each class that's passing it, but it is not extending the class. It is just taking the method on the prototype of the class that's passed in and adds those methods to this class. So that's what it does. The methodizes method, that's what it does, basically. So again, to summarize it, the methodizer class, what it does, when you pass the list of class, what it does, it goes to each class and check if the method of this class is not already on the prototype of this class, then it adds those methods to this class. So now all the methods found on each of the class passed here are now added to this class. And I hope this is clear. As we go through it, we'll see what it means. So that is what this one does. What about this? Well, it says set max listener to infinity. Now, as we said earlier, this base class extends the transform API, and the transform API extends the event emitter class. And the event emitter class has a maximum listener by default. I think it's 3 or something like that. Now, if you go beyond the listener, as you add listener to this class, if it's more than that, it will give us an error. To avoid it, we tell the class that, well, we want to use as many listener as possible, and please don't give us error. So that's what it does. So it set the max listener to infinity. So that's basically what it does here. Now we have seen what this one does, what this one does, what this does, and what this one do. I would like to show a little bit, a glimpse at this thing here. I want to focus on this one a little bit, and the reason we're extending this one. So for example here, let's see if I wanted to declare something. I can say, for example, I want to create a node base. I can say constant like this here, constant base. For example here, I can say base here equal node base. I can do it like this here. This is okay too. But the real power of this one here, I want to show the power of this one here. As I said earlier, when we instantiate this class and pass in an object here, what this one does, it takes each key of this object here and add the key to the prototype of this class. So let's see here. Now I will pass an object here. For example, I can say account, for example, and again, it can be anything. It can be another object, it can be a function, it can be another class. So for example, this is going to be a function, for example. I can say console.log, for example, here. I can say account, for example. Just like that. Now, this function here is part of this class. I can basically say like that now, account, just like that. And then let me go here like this here. If I go to node base here, see this account here. And this can be anything. I can even add another like string for the name here. I can say John. I can add anything I want. If I want to, I can even add another class as well. I can say like user, and I can say class user. Now I can even use base user like that if I want to. I can also say base name like that. I can even say, for example, I can even say here user constant user equal new base like that user. I can do that. So that is the power of that thing. That is the power of this line here. You can basically add anything to the prototype or to the class here. It can be object, it can be string, it can be anything you want as you instantiate this class. So that's one of the power of this one. The other thing I want to point out here as well, the reason we are extending this one is as we said earlier, so this one extend the event emitter class. So now we are able to do things like this. I can say here, for example, here, I can say based on user has register, for example, like that. And I say console dialog. And then I can say base your emit user has register, like that. And I can say sure username equal John and email here equal John at email.com. If I go here and see, now you see here, now I can use this one here. I can do things like that because I'm extending this class here. I can use things like that. Another thing I can do as well, another power of it is this here. So right now, I also have, before I do that, I want to explain this thing here. Now it's a base from iterable option, for example. Now remember we said that this transform stream extend a duplex stream. That means this stream is both readable and writable. So that's why we're using this one here. So another way to use this one, for example, here, let's see, I'm going to come here. And also I already show you this part as well, as I explained earlier. So the default here, that means if this object property does not exist on this class, it will add it to it. So since we auto invoked it, that means it immediately adds it to it. So now I can do things like this here. I can say, for example, constant writable equal base create write stream, like that. I can say user.json, for example, like that. And then I have base like this, get iterable, get from iterable. I can pass an object. I can say first name here equal John, and I can say last name here equal Doe, like that. And then I can pipe this one into this writable, like that here. Now if I do it like this here, and I go back here, see, that's what we have here. It just created that thing for me here. Now I'm using things like create write stream to the file, but what it means, what I mean by stream here, writable or piping, it can be anything. I can send data over the wire to another server that's set on a different on a different side of the world, maybe in China or another country, direct like that, because this is the real power of stream. So that stream does not have to be a file system. It could be another network. I can send over the network with that thing. So with this class here, it gives you all the power. You can do file system, you can do real-time communication, you can send data over the wire to a different network, to a different computer, a different system. You can do all of that. So that's a glimpse of what this thing can do. So now we have all this power into our hand. This is why we're using this base class. That's why we're extending this one in the first place. That's the reason we're using all these one as well. So this is basically the part on this is basically this class, what it does. So that's what I meant earlier, that this is the heart of the project. By understanding this one, we use the full power of Node.js and the API. Now enough for this class. Now let's see why we have this class and how we're going to use it in the first place. To do this one, since we're running out of time, I will show only a few things here. So one example of this is our model here. If I go to model here, this is using MongoDB. Again, we are not using Mongoose because we don't need it. I personally believe this Mongo client from the MongoDB is enough to do everything Mongoose does. And it's very simple. It does Everything is clean. With this one, we have all the method on the MongoDB to do the CRUD operation. So we are using this one and we create our own class. So we are all this class 1, 2, 3, 4 classes. And as we see here, I will go through the classes in the first place, but I want to go here. This class here, this one here, we call a Mongo class. And then we can see here, we require this one and this one and this one, and we are passing this one into the metodizer here, as we said earlier. So what it does, it takes all the methods on these classes and on this class and adds them to the MongoDB class. So all the methods now from each class, they are added to this class here. That's why we're passing those one and these classes here. Again, this is not extending the class. It's taking the method and adding them to the prototype of this class. Now, I won't be able to go through all of it, but what I want to point out here is our query here. So we got a Mongo client here and a Mongo object. For example here, let's take one example to see for, let's say create, for example. We have a method here called create collection callback. Okay, we don't want to, I will change it. I don't want to create, I will go to create here. Create callback. This is a callback function here. Now, how does our base class help us here? Here, this is the camel case. So when you have a class with callback here, I want to focus only the name without the callback word. So here we've got to create. This is basically how to create an object in the MongoDB. This is the if you go through the MongoDB document, you will see that. So what this one does, it takes data as argument and the collection name as argument, and then it creates that data, it adds that data to the MongoDB database. But more important, what it does, as I said again, we focus on the create name only. So when this method is called on success method, it emits an event of the name create, which is it emits its own name as an event on success. And there is an error, it emits its own name -error as an error method. And then we're using this emit here. And we're able to use this emit here because our base class extends the transform class, which extends the event emitter class. That's why we are able to use the emit event here. That helps us keep the code clean and more efficient. Now that's what it is. That's what it does. So whenever we see the create callback here, we focus on the callback here. Now, if you go back to the callback here, for example, here, let's come back here. Now we have a create here. So that's exactly what we do. We still have the on here and emit here. So I won't go back through all of this here, but I want to make sure that we have the create method here as well, and it emits the event as well. Now, when you look at all those things, all this method we saw here, the create event now, because we got a callback here, and this is that callback class here, it is passed to the metodizer here. That means this create method is now added to the prototype of this class here because we pass this callback here. So this is our MongoDB main or base model class. Now, how do we use that? Now to use it, let's come here to our model class and take example for the user class here. Now the user class extends the MongoDB class. That means it has all the method on it as well. So we have the user class here. Now, how do we use it? Now let's go back to the controller, for example. Let's see let's go to the HTTP controller and see the users controller, for example, here. Now, for example, we see the index method here, and you can see the real power here now. So to get all the users from the database, we only need 3 lines of code. That's all we need to do the cross. For anything we want to use here, we just need 3 lines of code. Actually, we need 1 line of code, basically. So this one is in case the error happens, the error happens. So again, as we said, in this one here, let me go back to this query here. We say here, when we call this method on success, it emits an event, and the event name, it's its own name as here. So if you go back here to our controller here, that's what we have here. If we call the method or on this model on success, it emits an or because it emits an OR event, so we listen to the OR event. If that OR event happens, that means we got our result and we send that result to our API endpoints. If there's an error, we send that error to the API endpoint. Now you see what I mean by that. So if you go back here, the reason we use this function, how do we go from this class to something like that without even knowing and without even worrying about what the method does? We only know when we call this method, it gets all the data. So here, now, to do the CRUD operation, we only need 2 lines of code, at most 3 lines of code. That's what we need here. And we can do it for many other things. Find by ID, we only need 3 lines of code. That's what we need. We get the ID. If we find this object here, we send it to the API endpoints. So that's basically what it does. So I hope you see the simplicity and the power of using something like that, starting with something like that and ending up with something like that. Now here, I'm showing you to do the CRUD here. We could do many other things. This model here is also a transform API. We can send info. If you picked up this data, we can send it over the wire to a different server if we want. It does not have to be our only server. We can send it to any network we want. So that's the real power of it. Here we're using MongoDB, even though it's using MongoDB thing, but it is still a Stream API. Anything we can do with a transform API, we can do it with this model here. So this is the power of it. That's the whole point of coming from here and getting here. Now, Stream APIs makes Node code very easy to read and beautiful and short and as powerful as can get. That's the whole point of it. So that is the whole idea. I wanted to explain this one. There's far much more you can do, but that's one benefit of using the class in the first place. So in this controller here, we have this index. We can get all that thing just with 3 lines of code, and it's very simple. If we want to get single one object, exactly 3 lines of code. It doesn't take more than that. We want to do edit and update. If we want to update, we do 3 lines of code again, just exactly as you see it here. This is the update method. If you call the update method here, because by calling the update method on this model, it emits an event. The name exactly as the name of the event it emits is its own name. So we use that to get the data we want, and we send it to our API endpoints here, and then if there's an error, we emit that. That's what it does. So this is the TCP routing here. Now the same thing can happen with this is the HTTP routing here. Now the TCP as well, we have about the same thing as well. For the TCP, it does exactly the same thing. We can use this. If you have the model here, you can use the model here. I didn't use it here, but it is the same, exactly the same thing. If you want to use a model, we put the same thing and do exactly the same thing. So this is the foundation of this project, and it can, because the way they structure as well, you can build as large as possible. You can put all your controllers here, you can put your views if you want, you can put your models if you want, you can put as many as you want, you can do whatever you want to do with it, however you want to do it. And then I wanted to point out a little bit about the TCP part of it. If I go back to the source here, let me come back here. If I go to the socket here, again, it's using socket.io. And if I go here, this is the socket.io here, which is, we got the Redis here, and we have this class here. We pass the server here. And let's look at this class here. This is the socket here. This one, it extends the server class on the socket.io. And when you take a close look at the server class itself, the server class on the socket.io extends the Stream APIs as well. It's a duplex. So really, if you think about it, we don't really have to use the socket. I use it because it's very easy to use. But really, with the Stream API, we can build our own socket.io if we wanted to. But we don't need it in this case. So that's what it does here. So we have here, and then we export that thing, and the server that is passed here, the server it takes in, is the Express server here. You got the Express app here. So now we have a socket here. So we pass that server here. So that server basically is the Express application here. That's what we have here. This is what we have here. I don't know why I put this one, but that's basically so I hope that makes sense. Let me go back here again. So how do we get the TCP work with our thing here? So here we have this one we're exporting here, but then for example here, let me go back to the route. For example, here we have a TCP, we got the HTTP route here. That's what we have here for the HTTP route. For example, for the user controller we saw, we get a method from the user controller and we put them to the route here. Again, that brings another thing I wanted to explain here. This is a class, a user controller class. But again, in JavaScript, everything is an object. So actually, the methods on the user controller class are nothing more than object attached to the user controller class. That's why we are able to use object distracting here to get the method on this class here. That's what we pass here. So this is the HTTP class, and those are the endpoints here. Now, how do we do the TCP one? Now let's go to the TCP socket here. Here we have here. So we are exporting this socket.io, and we are exporting this namespace here, which is app. Now let's look at the namespace here, for example here. Now we had the IO pass in here. It takes an IO, which is IO from socket.io. So we require the user namespace. Now let's see what a user namespace looks like. Here we have the user namespace here. Again, this is the user controller from the TCP controller here. Again, the user controller on the TCP controller is another class with methods, which are these. Again, this class is still an object, so we can do object destruct. We can do something like that. So that's how we get it. Now we pass these one here. Those are the method here, and it takes the IO and socket and pub and sub. Okay, now pub and sub is another thing we do with Redis. That's where the Redis comes in. That is subscribing and publishing here. Those subscribing and publishing here, this what we see here, this method here on this class here. If you go back to this one here, go to controller TCP, let's say user for example here. Those are the methods here. See this method store, it takes IO and socket, sub, pub, and some extra argument. For example, the sub can subscribe to event emitted from any server. It can be NodeJs server, it can be Laravel server, any server. So it subscribe to it. And when there's a message here, it emits another event with this object or whatsoever that is. So that's the pub and sub. So, but what I want to point out here, we have this store method here, and we have those argument paths here. The same argument here, those are exactly the argument we see here. basically. So now we have this namespace here, and we pass on connection. So that's the event of the socket.io on connection when the server is listening to the connection event. And when that happens, it emits this function here, which is this one. So all the things that included that. So on connection, that means when the server or the client is connected to this namespace here, once the client connected to this namespace here, it listen to this, the server listen to this function here on connection. So that's basically this the TCP part of it. You got a sub and pub here, and everything is here, and this is the main thing here. So the IO is passed here. That's the IO from the socket.io, and that's how it works. So we have the namespace here, and we have what the server can do when there's a connection to this namespace, and whatsoever the server can do when the connection is to this namespace is to run this function, and this function here runs all the methods on the user controller. So that's what a TCP is, and I hope this is clear enough. And you can add as many as you want to. That's what I mean by you can scale this application. You can add as many as you want to without worrying about too much about how to do the configuration, where to put it. You can just put everything here. If you have another router, you can put it here and export them here, and then immediately it's here. And the whole thing here is read by the server here. That's basically it. So I hope this is clear enough, and that's one way to build a real good or large scalable TCP and HTTP server in Node.js, and also use the most powerful tools in Node.js using Stream API, and one of them being the Transform API. So this is the project. If you have any questions, please let me know. I can improve it, I can do a few things, but that's what it is. Thank you very much.